My name is Sal Lopez, and I'm going to be working on optimization.
Yeah, you are?
What is optimization?
I don't know. What is it?
I'm here with my friend Isaac. Do you know anything about optimization?
Nope.
I rest my case.
Josh, what do you know about optimization?
Nothing.
Oh, shit. How much do you know?
0.
You guys ready?
Yeah, we are.
Let's dive into calculus.
Okay, in today's video tutorial, we will work on optimization. What is optimization? Optimization is using calculus to find the max and mins and solve real world problems. Example of a problem. A dairy farmer wants to build a fence. It will go around a rectangular pasture adjacent to a river and contain 180,000 square meters. The question: what are the dimensions required to use the least amount of fencing to make this pasture and fence to What are the dimensions required to use the least amount of fencing possible? Well, okay, this is where we get to solving the problem in 3 easy steps. Number 1, we have to get 2 equations. Okay, so here's the river and here is our pasture enclosure that we need to fence around. So we know the area would be 180,000 square meters, and so we have area equals base times height. So now we have base, 2 bases, and 1 height. And then our perimeter is the fence going around it. We're gonna have two bases and one height, because the river does not, we don't need a fence around the river, so it's just gonna be 1 height. So first we have to solve for b. 180,000 is equal to bh, which is the area, is equal to base times height, and then so to find b we need to divide 180,000 by h, and that gives us b equals 180,000 over h. Number 2. So now we move on to step 2. Plug in the equation into the other one and simplify. So we plug into the perimeter equals 2 base times height, and it's going to be turn out to be that. We simplify, and that's going to be equal to this. And the reason that I made it a negative power is that will make it easier for later when we have to take the derivative, which is step 3. Take the derivative, set it equal to 0, and then solve. Okay, so first we take the derivative, which will equal negative 360,000 h to the negative 2 plus 1. Make it equal to 0 because we're looking for a minimum, so we're going to have to find the minimum of a derivative, and that means we need to set it to 0, and here it is. And we put it back under here because it will make it easier again. And so this is it, and then simplified, and then simplified again, and we come out with positive negative 360 square root of 360,000, and we can't get a negative number because distance is positive all the time. So we just have this h equals square root of 360,000. Now, square root of 360,000 being 600, we get h is equal to 600. So we got 1 dimension, but now we need b. We need to get the other dimension, and so what we do is plug in back to that first equation we got when we isolated b, and we get 180,000 over h, and then substitute, and we get b is equal to 330,000 meters. And so the answer is the dimensions of the fence would be, to use the least amount of fence, would be base equals 330,000 meters, and the height would be 600 meters. And yeah, that's about it. Thank you.
Are we done now?
What do you mean?
With optimization.
No, dude. You still gotta study.